Bismillahirrahmanirrahim. Assalamu alaikum. Let's define sigma field. Let omega be sample space. What do we mean by sample space? You know from your probability. Let omega be a sample space, then a family of subsets of omega denoted by calligraphic F is said to be sigma field if following conditions hold. Number one, empty set belongs to this calligraphic F. Number two, if A is in this calligraphic F, then its complement, that is universal minus A or sample space minus A, is also in this calligraphic F. And then third and the last property that it has to have is if A1, A2, A3, so on, so is a sequence of subsets or offsets in this calligraphic F, then their union A1 union A2 union A3, this union is also or belongs to this F. So sigma field is nothing but it's a collection of subsets of sample space. So what is a sample space? So you know the sample space is defined by the collection of all possible outcomes. So the sample space is collection of all possible outcomes, collection of all possible outcomes of an experiment, outcomes of a random experiment, right? And every subset of this, you know, any set that is subset of this is an event. And you know that when we defined, we said that this sigma field is containing the subsets of this, you know, omega. So what does that means? That means that this sigma field contains events, or we will be familiar mathematically. We also say that if there is any element in this you know, sigma field, we say that this element or this set is measurable. So when we said that this belongs to this F, that means that nothing should be, you know, measurable. And at the same time we said that if A is an F, that means if A is measurable, then its complement is also measurable. So happening is measurable, then not happening is also measurable. And because this empty set is an sigma field, so its complement, which is whole space, sample space, so it is also in the sigma field. So that means that this sigma this sample space is also measurable. So we defined so far the sigma field.